Okay, so we're back, and today I wanted to do something a bit different. And the idea is, so now I got a microcontroller, and this microcontroller is this guy. Bang, you can see it him here. So it's the Arduino Nano ESP32. So this is a joint of two different microcontrollers. Microcontroller one is, well, Arduino, and then the SP32 is a different microcontroller that allows us to also connect via Wi-Fi. And that's gonna be, so here they also have Wi-Fi and Bluetooth, which is nice. And let me just give now we're gonna do something a bit faster running. And here's the view, right? And this view I want to also compare with the schematics I have here. Don't mind my screen, which is a bit too crowded. Wait, this I want minimized. Yes, this as well. And here. So this is the view that really matters for us. And what we're gonna do is to make a basic thermostat. Super simple. We're gonna get to this soon. So basically, this is the face of the microcontroller, and each one of these squares is a single power, not a power plug, but it's a plug. And these plugs receive different voltage information that can be used to be fed for analog and digital outputs. And here, so this is the view. Now, if you compare this view with this view here, let me just put this on the left. Let's put this on the left again. Yes. So if we zoom out, we're gonna see that I try to make a replica of this guy here. And this is what it means to us. Here on the first entrance is gonna be the source. So here on the Yacht 1, we actually put, oh, this is huge. We actually put the USB-C charger, and he's gonna be 5 volts, and then internally here it outputs 3.3 volts on this DL2, which is this stick here. And okay, so what we want to do is we want to connect this guy, which is a tiny sensor, and on the next parts we're gonna see it live. But so this guy, it's this one. It's a low power linear active thermostat. Wait, oh no, it closed my screen. Wait. I'm gonna go back there. And our guy is here. Yes, so coming back here, this is our guy, and how does it work? The idea, this guy looks like this, right? So he has 3 legs. One leg is for the ground, so it's where we're gonna output our circuit. This is the voltage that we're gonna be measuring. This is our target. And this is the input. So the 3.3 volts are gonna come inside here. And this is a suggestion of how we'll build it, right? And here we're gonna also add a small capacitor just to take off any extra charge that comes, because the 3.3 voltage is not that stable. Okay, so the goal here is what we're gonna do then. I'm just gonna do the lines, and then we're actually gonna see how our guy is working. So here, what we wanna do is to connect this. I wanna add a different connector. I'm gonna make like a solid connector and not actually pull from it. But we're gonna do, this guy is gonna come here, right? This goes here. However, I want them to connect, mate. Okay, it doesn't connect, but it's alright. And after this guy connects here, I think I can use the arrows. Yeah, I can use the arrows, so that can just be the direction of the current. It helps. Okay. And then from this guy, we are gonna do this. Yeah, this is, I think it's not the best thing to draw current, but well, we're gonna do here. And since I'm lazy, I'm just gonna do like a capacitor. I know that's not a symbol, but the capacitor is gonna be this. Oh, this guy here. And we need another arrow. And this arrow starts here. This arrow goes through here. Then these guys, they will join the output line. Let's make it just bigger. This is the ground, and let make it clear that these guys are not already crossing. Okay, this is on top of it, and then this guy outputs here. So here we have the capacitor. All right. So this is gonna connect here. It's gonna feed this guy. Any extra voltage, it's gonna actually go here, the capacitor, and then this is the output, and this is what the guy we want to measure. So here, let's also stretch this line, and this guy is gonna come up and do this. Damn. Okay, I'm gonna have to copy another arrow. Arrow bottom is here. Come on. Come on. Okay, and this one jumps directly there. Okay. Damn, these arrows are getting ugly. Let me just remove this. Okay. And this goes there, and we need the ground to close the circuit. So this guy also needs to feed its output into the ground. So this one goes here. This one goes, well, here. Ugly? Yes, but functional. Let me save this. Okay. Now, after seeing this, we actually need to go and look at the controller. So this part of the video is done. Okay. Okay, I hope everything can be seen from here. So this is the microcontroller, right? So make this is the point of focus of the screen. It's here. Okay, so this is the tip. Okay, so this is the microcontroller, and here we're trying to do exactly what we saw, right? So let's just follow the arrows. Let me just take some pointer. So this is the pin of the 3.3 volts, right? And we're gonna take this pin from 3.3. This guy, it's actually here, the orange line. So the orange line goes here, and here we have a power line that's gonna split. And this is the first knot that we put in the video. And this knot's gonna split and go feed the thermostat. Here is our thermostat, you see? It's quite small, and it has like these big 3 legs. And so here it splits, and here is also on the same line as the first leg of the capacitor. So the power goes from here, this leg, here, and jumps out to this power line. And this line is line 23. And then the red cable jumps up and goes back to the ground line, which is the line 14 here. And going to the thermostat, it has 3 legs. One leg is the ground, is this orange. So the ground just comes here on line 27, jumps up, and it's also here on the connected to the ground. The middle one is the analog value that we actually want to measure. So this guy goes to A1, which is gonna be where the port that we're gonna watch our sensor. What else is missing? And there is this leg here. This leg goes here and gets taken by the green line, right? Sorry, this is, yeah, the green line. Wait, let me just rewatch it. Wait, what? Yeah, it gets taken by, no, this is the blue line, sorry. The blue line feeds it in, and then the output's on the green, and the rest is ground. And to turn this guy on, what we're gonna do is this. So you're gonna connect here. And you're gonna see that it's gonna, now we're gonna have to jump back to the screen again, because, well, here there's nothing more to be done. And we'll leave the guy here. And okay, now that we are back to the screen, here so this guy is the manual of our thermistor. And so here's what we just saw there. And this guy, it's also, this setup is exactly the same, right? So this says a microcontroller, is a different brand, but well, it's the same thing. And this is the input, whereas we put in the cable, la 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 la. And this, oh yeah, I just didn't mention, but yeah, this is the same value, 0.1 microfarad. And if we go, so this guy is analog, and what it does is that this V out is gonna change depending on the temperature. So we measured this, and there's a curve that's gonna say It's this guy. It is the currency. I want voltage versus temperature. I think it's gonna be here. No, 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 no. Yeah, here. So this is roughly it. So what we see is the volt, and at 0 degrees, and we're just talking about Celsius, it's gonna be 0.5. And there is this rule. So this is a linear approach. And then we just look here. It's also so this is the equation we're gonna use to structure our logic, right? So is the voltage that's on the output equals the temperature coefficient, which we also took it, and you're gonna see in the code soon. TA is the one we want to measure, right? So basically it's V out minus V at 0, and V at 0 I already know because it's 0.5, right? So 0.5 goes here subtracting, and it's V out minus V0 divided by TC. And now if we go to here, now you're gonna have to trust me that the Arduino is connected there. But you're also gonna see him here. So this is the code part, and it's rather simple, right? So coding the Arduino is basic. So first on the setup, we're gonna say every hardware that we wanna use, and we wanna initiate them. And let me just put here so we don't do spoilers. And so I just push, after I write the code, I need to push it here on the upload, and we send the code, and the code executes in a loop. So here the setup, what did I do? The serial is the class that manages the port, not the port, but the channel we are listening to, right? Here, we are defining this 12-bit resolution because it's how the microcontroller is built up. So it's built in steps of 12-bit for the voltage. So it reads the voltage in let's see, in layers, and each layer is a 12-bit, and the total of its resolution is 4096 minus 1 because it's reserved for memory. I think that's it, yeah. So then I define these samples because if I just take every output it says, it gets too volatile. So I do a bit of an average. So every 500 microseconds, which is, well, 0.5 seconds, it does an average of everything that it captures here. And then we divide it by the number of samples that we've taken here. And this is the formula we saw there. So the output voltage, it's actually here. So we define the voltage, and then we're gonna see here. So the voltage is the raw value that's spit out here and is also taken from here, divided by the resolution of our microcontroller, right? And this is the voltage, where is this guy? And this is also the hard-coded value for the hardware, right? And this guy means here, right? This TC. And when we go here, we just have the temperature in C, right? So this is gonna be in the loop. And here in the serial print is just the values that I wanna keep shooting and listening. And on this first part, we're just gonna wrap up and make sure that we are having the temperature output. And then in the future, we're gonna make a server, and we're gonna export this to the server, and the server is gonna stock it, so we can make a time lapse out of it. And now, how do we watch it? So we go to the serial monitor, right? And we say the channel that we are listening to, and here it is. So basically, the V0, it's 500 MV, and every degree Celsius that it goes up, then it adds 10 milliampere. I think that's written somewhere here. Yeah, it's basically this. Now this is the accuracy. Well, you're gonna have to trust me, that's here. And yeah, so we already have this temperature, and the goal now, because we're just listening to it, it's to also inject here in the code some authentication to join in the Wi-Fi. But first we need to build a server that's going to be watching to receive this package. So it's going to be a very simple package with the voltage, the temperature, and then we're going to hold that down. And that's going to be done by a Raspberry Pi, but this is going to come on the second step. Well, that's it.